Hello and welcome to the Solve1 YouTube channel. My name is Ray, and in this video, SpotMicro part 31, I'm still working on this WaveShare servo driver board. So as you can see, it is installed here. I have used one of these little boards, and I'll try and find a link to it and put it in the description. This is actually something installed over the bottom side of a Raspberry Pi. Let me just move this out of the way. This one's a Raspberry Pi 3, but it works for a Raspberry Pi 4 as well. You stick this on the underside of the board, like so, and then you solder through to attach this header to the bottom of the board. That leaves the GPI header pins available for you to plug on other boards if you want to. This big terminal then allows you to connect 5 volts directly to the board, and has provision down the bottom here for, if this thing would focus, it would be nice, serial, RX, TX, and the 5 volt ground as well. There's also a switch there if you need to turn it on and off. You can also solder jumpers in to keep it on if you need to. So as part of installing that WaveShare board, I came to the conclusion that I really wanted to be able to turn servos off separately and independently from the rest of the control system, which is just a matter of showing power to the servo. And these cheap Chinese-made PCA9685 servo driver boards allow us to do that quite easily. These have 2 lots of power to them, essentially, VCC, and if I can get this to focus properly. There we go. You can see I've got VCC on the bottom left there and V+. Now V+ comes from the green terminals, which is our main power supply for the servos. The VCC will supply power to the PWM chip, which is the PCA9685. So that allows it to keep running. There's also a power light on there, and I can't remember if that was connected to the VCC or the V+. I think it's VCC. So one of the issues I've been running into is when the servos make any sudden movements, or multiple servos make movements, it puts a strain on the power supply system on the power coming in. Mostly because the wire I'm using up here is a bit on the small side. That's 0.75mm cross-sectional area bell wire, and there's about 3 meters of it coming from my power supply. So while my power supply is outputting 7.4 volts and is capable of supplying up to 12 amps, the voltage drop through that wire is enough that the power supply built onto that WaveShare board is not big enough to keep the PCA9685 on it powered up. Now I daisy chained the I2C off the back end here of that board, and that feeds the LCD display on the back and also the MPU6050. The red and black wires here are connected to one of these, and that supplies the Rasperry Pi, and that's off a separate switch mode power supply like this one. This is capable of delivering 4 amps, and I've also added an additional large capacitor for surge protection or sag protection in the back of the robot behind the LCD display. This means that when there's a sudden movement on the servos, the power coming in can sag. Because there is very little in the way of sag protection in this power supply, this chip, the LCD display, and the MPU6050 all perform a reset, or a partial reset, which is even worse. And the result is the whole 3 of them crash, essentially, causing the robot to start doing some weird and wonderful things. I've had a lot of errors, and I've tracked them all down to if there is a multiple servo movement happening. When the robot is walking, we are going to have up to 12 servos moving at the same time under fairly heavy load. So this is not good enough. As a result of that, I am going to pull this board back out. It is not going to do the job I want. There's no real easy way to get around it. I could potentially reconnect this to the pins up here, but the truth of the matter is the board is not up to, like, I've already modified the board once. It's really not up to doing the job as advertised. You literally need a constant current or constant voltage power supply at these terminals that cannot sag. So it must be able to supply 10 amps at the voltage of your servos without hesitation. So the 7.4 volts I'm supplying at the end of a cable is just too much of a voltage drop for it to work properly. I have started working on my own design because I do like the idea of having the board as a hat sitting on the Raspberry Pi. The board I've been designing, and I'll try and put an image up, it has the MPU 6050 built onto it. I've also added a PCF8574, which is a 8-channel I2C IO expander, and an NPR 121, which is a 12-channel capacitive touch sensor. All these devices are supposed to be supported by my robot lab. I'm also wanting to know how much power is being drawn by the servos on a per lead basis. So I've also added 4 INA 219 current sensors, and so that'll be groups of 4. I may yet add a 5th one in. I think I've got the room on the board to do a 5th one. I'm also thinking of doing a secondary daughter board on top and moving some functions up onto the daughter board, and also adding in an amplifier audio system. It's still a work in process. I also would like to have had some analog inputs, but I'll look at that in a future version. So today I'm going to pull this apart. So obviously that means we have to turn the power off, which I've done, and it involves pulling all of the servos out again. Now, because I've added this to the bottom of the Raspberry Pi, I can't get the PCA9685 back in on this side anymore. So I'm going to have to put it on this side, move it up to this end and put it up on this end, and probably have to bend these pins over to make it easier, and rewire from that. So that's today's plan. It's a shame that they didn't run separate supplies for power for the servos and power for the Raspberry Pi. It probably would have been a good design if this was a 4 amp power supply instead of a 3 amp with some sort of surge protection, additional capacitor for it to charge up and discharge through. And if the V-in had been 2 separate plugs, one for the servos and one for its power supply, it would have been a more useful kit, in my humble opinion. And then you supply whatever power you need for your servos at whatever voltage you need. So in the case of the servos I've got installed at the moment, they're the HV servos, so they're good for up to 8.2 or 8.4 volts. Actually, I've got a box. 8.4 volts. So that would have been handy. Okay, so there is room at the back here for me to mount my PCA9685. I did have one there previously, and so this can mount like so. And then I've just got to wire it back up again. And that means that the wires from the back servos are now doing the directions. I could rotate this around and it will be less of a stretch for them. And bring these wires up through underneath and then come into the terminal here. I think I might do that, that might be better. Now these are the posts that I was using to mount the WaveShare board on. And I do have this one which is the same size. I thought it was bigger. That's the no good one. Thought I had a taller one out that I was playing with. I want to remount the PCA9685 a little bit further down. Actually, these are taller than these. So I'll mount that down here. Might have to bend the over a little bit. Or I could mount it on the other side. Oh no, I don't want to mount it on the other side. If I do that, that'll create more headaches for me. Has to go this way. I'll look at that in a minute. Now this wire here is same as this one, so but it's off a different switch-mode power supply. So I have two of these mounted in the back. One of these has a large storage capacitor on it to help protect the Raspberry Pi from static. And that's what this supply is. The blue wire was my ground. The ground is my battery supply. This one, I haven't installed the terminals on there yet. They were part of the same batch, so they should be the same settings on the chips. One of the other things I did discover with the WaveShare PCA9685 is because it was from a different batch, the frequency that this chip runs at with its onboard oscillator was slightly different to the WaveShare one. And the net result of that is the centers of my servos were all moved. This is actually a known issue with these. That's something that's not that hard to sort out. The only thing with rearranging and turning the board around the way I am is all my wires are going to cross, or I have to recode the program. So now I'm going to cross my wires with easier. This back hole has to be band off. I've got a mount of MTU6050 on it. Keep bumping the camera with my claws. I do apologise for the image. I'm going to take this off the stand. Give me a more stable base to work on. Now these standoffs and screws are M2.5 millimeters. Oh crap. So I've just spotted another issue. When I mount that there, it's over the top of my terminal for the servo, so I'm going to have to bring it back over to this one. And before I glue that up, make sure that standoff is tight. I notice this was twinging already. Enough. Okay. So I've got servo power connected here, and I have got power to the Raspberry Pi through this board. That's a connector, and they just unplug like so. Very convenient. You can solder your wires directly to one of these, but once you do that, you can't disconnect the power wires off the Raspberry Pi. Alright, so down time my wires here. My servos. So from memory, my servos were inside with the back because it was convenient. The long one is for the shoulder. I'm going to go shoulder first. That's terminal 4 there. This one goes down to the foot, or the wrist. And this one is the arm. If I've got it wrong, I can always change it later. It's easy to tell if I've got it wrong. The servos will do some funny things. This one, I plugged in my not all in back to front. So this is from the right front leg. That's the connection to the MPX6050, but I still need my main connection for the rest. This is where I really need to think about what I'm doing here. Let me just bring up the WaveShare board information. Okay, so this is the wiring diagram for the WaveShare board, and you can see here we have P1 here, which is the powering. It's got a small 10 microfarad capacitor, which is not very much of a filter coming in. I've got a much larger one for the Raspberry Pi. That then feeds through a switch mode power supply. So this is the switch mode power supply chip, capable of supplying up to 3 amps. And then we have an inductor here. So it supplies VN through that switch and the flyback diode for the switch mode function. And that gives us 5 volts here. That 5 volts can be connected to, there it is, the 5 volt with that 0 ohm resistor. So it can power a Raspberry Pi board from that. From there, the 5 volt also feeds into this 3.3 volt voltage regulator, which then feeds the PCA9685 chip at this point here. And you can see there's not much in the way of voltage regulation at all on that. Surprisingly, I thought there would be a voltage shifting circuit on here, and there doesn't appear to be. So that voltage shifting circuit should have been for the I2 I2C bus. So we've got PSDA and PSDA, PSCL, PSCL, and they've connected that directly to the header. So the header are the pins on this end, and they've supplied 5-volt and ground out, and then those pins with no voltage conversion. So that's a dangerous thing to do. If things go horribly wrong, you can actually feedback and blow up your Raspberry Pi, particularly if there are pull-up resistors on your devices. Now, the LCD display in the back of the robot does like to run 5-volt, and it does have pull-up resistors on it, which is a scary thing. So it's trying to pull that bus up to 5-volt, and the Raspberry Pi's GPIO is only 3.3-volt tolerant. So yeah, there's a few questionable design choices they've made on this board. I can see the advantage of having a switch mode power supply in there to supply the Raspberry Pi and the PCA9685 chip, but at the same time, you really don't want that same supply driving your servos. You want to have a different supply that might be on a separate switch, so you can run your Raspberry Pi without running your servos if something is going wrong. You also want more than 3 amps for your servos. As soon as you start drawing 3 amps, you no longer have enough power to run your Raspberry Pi and everything crashes. So there's a lot of bad decisions in my view. If you look at this board, this is again a cheap Chinese knockoff of a PCA9685 board that was originally designed by a group. You can see that big capacitor there, and that big capacitor there is to help handle those surges. There is no big capacitor on here to handle those surges. So yeah, a few things that are not ideal. Okay, so let's look back at what we're doing with our robot anyway. I've got a few things I've got to change with my design as well with the hat on design to go on for servo control. Okay, so back in here, I've got this wire which I had connected to the WaveShare board at this end, and that's got 5-volt, or had 5-volt ground SCL and SDA on it, and I still need to connect that back to the Raspberry Pi somehow. But I also have over here the hidden away underneath all these terminals, the connection for the PCA9685, which now also has to be connected in. Now what I could do is make a new jumper cable to go through. Made a few of those. The other one I could do is make an extension for this. This is the old wiring loom I had, and I've cut a bit off it somewhere. So it went down this way. Can't even see where I cut it off now. Oh, here it is. Cut it off from down here, because that plugged onto the Raspberry Pi, and then that goes down to the board. Yeah, and that then daisy chained on to the second PCA9685. No, it didn't. It daisy chained on to the Arduino. Right. That went on to the other side of the Arduino, and this was for a level shifter. Alright, so still have my headache. We'll do here. still feed the PCA9685. I can remove this wire. That will go onto the PCA9685, and this can still plug onto down here. We're no longer supplying power on these two big terminals. We could probably pull those out. Don't need them anymore. Somewhere along the line I've managed to break this one. And that was the stereo connection, which I don't need anymore. So really I only need, and this was planned originally to be a shutdown. The GPIO wasn't working on the Raspberry Pi in my robot lab initially, but I think that's being resolved. I haven't tested it yet. So this orange wire is 3.3 volt. Now it's the red. Now the orange wire is not 3.3 volt, that's the shutdown wire. The red wire is 3.3 volt. It goes to this one as well. Let's clean this up and pull a few of these out. You might be able to see it. This first terminal is empty, and that goes to V+. We do not want to feed V+ back to the Raspberry Pi at all. That could be any voltage that we're using for our servos. So if it's down the track we decide to put even higher voltage servos again, we really don't want those going back to the Raspberry Pi. The 7.4 volts I'm currently using, we certainly don't want back at the Raspberry Pi. The blue wires here are ground, and the yellow and green wires here are SDA and SDL. The red wire here, which is orange, like this Y line, is our VCC, in this case it's 3.3 volts. So I am driving this at 3.3 volts. Now if I can get it. Okay, so that's now plugged in. The spare orange wire goes back to the GPIO, and when I've confirmed that the GPIO is input-output pins are working as needed, we will probably use that to connect back to we'll use that to the enable line. So with the enable line, if we drag it into the ground, it will turn off the output from the PCA9685, which is sort of like a software shutdown. Now at this point I can connect this straight back to the MTU6050 and it's going to work. And I can actually do that. Right. That will work. It's not an ideal situation, and I still haven't powered or sent data through to the LCD display on the back, and that's what this is. So this is wired to suit the MTU6050. What I could do is instead connect that into like a jumper or a Y connection at some stage and then feed back that way, and that'll drop the voltage on my LCD display from 5 volt down to 3.3 volts. It was never brilliant at 3.3 volts, but it's better than nothing or potentially blowing up the Raspberry Pi, which, as I'm looking through the media, is starting to become readily available now. Now they're catching up with the backlog. So I'll work out the best way to do that, and I'll let you know the result later on. So this video is starting to get a bit long. If you like these videos, don't forget to click on like and subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account, and you can join my VIP Patreon, Very Lucky, and my Builder Patrons, MRL 45 and Micro, to support this channel. And I do try and get the videos out to them early. I've been running behind on videos this last month, but I'll try and catch up where I can. If you've got any questions, you can always leave a comment down below, or you can join us in Discord, and not only myself but others can also answer your questions as well. And we'll see you in the video.